Now, we all know what's thought to have killed off the dinosaurs, but now scientists say the asteroid that's believed to have wiped them out 66 million years ago.
What if the asteroid that wiped out the dinosaurs wasn't a lone cosmic killer? Recent research reveals that this infamous space rock had companions, multiple asteroids, that may have contributed to the cataclysmic event. Dive into the shocking details of this celestial assault and uncover the truth behind the end of an era for Earth's most majestic creatures. What's the truth? The extinction of the dinosaurs, a cataclysmic event that happened approximately 66 million years ago, is often linked to the impact of a colossal asteroid that hit the Earth with devastating force. However, recent research from Heriot-Watt University unveils a shocking twist. This infamous asteroid may not have been alone in its lethal mission. Scientists have unearthed compelling evidence suggesting that a second, equally catastrophic space rock collided with our planet during the same fateful year, igniting fresh intrigue into the events that led to the demise of the great reptiles that once roamed the Earth. This second asteroid, measuring around 1,640 feet or 500 meters in width, slammed into the ocean just off the coast of the Republic of Guinea in West Africa. Dr. Wisdeen Nicholson, the lead researcher of the study, attached this monumental impact to the Tunguska event of 1908, where a 50-meter asteroid exploded in the atmosphere above Siberia, leveling trees and causing widespread chaos. The implications of a second asteroid strike during this crucial period in Earth's history have left scientists both excited and anxious to unravel the mysteries surrounding these monumental collisions. The initial hints of this second asteroid emerged in 2022 when Dr. Nicholson and his team were poring over seismic reflection data of the seabed in the Atlantic Ocean. What they discovered was astounding. A depression measuring nearly 5 miles or 9 kilometers deep, which they suspected could be the impact crater of a cataclysmic event. Armed with this tantalizing information, the researchers employed high-resolution, three-dimensional seismic imaging to delve deeper into this geological mystery, confirming their suspicions with newfound clarity. The crater, now dubbed the Nadir Crater, bears the marks of a violent cosmic encounter. Its age aligns with that of the asteroid responsible for the dinosaurs' extinction, and the level of detail captured in the images is unprecedented. Dr. Nicholson expressed awe at the findings, stating that there are only around 20 confirmed marine craters worldwide, and none have been documented with this degree of intricacy. The data they collected allows them to visualize the crater in 3 dimensions and explore its layers of sedimentary rock, peeling back the Earth's crust to reveal the inner workings of this ancient geological formation. Initially, the team estimated that the second asteroid measured around 400 meters in width. However, with the new 3-dimensional data confirming a larger crater size, their estimates have now increased to a range of 450 to 500 meters. Dr. Nicholson further explained that the orientation of the crater, observed through spiraling thrust-generated ridges encircling its central peak, indicates that the asteroid approached Earth from a low-angle trajectory between 20 and 40 degrees to the northeast. The impact speed, based on their preliminary analysis, is thought to have been about 20 kilometers per second, or 72,000 kilometers per hour, a staggering velocity that would have released an unimaginable amount of energy upon contact. In an effort to piece together a timeline of this ancient cosmic event, the scientists meticulously analyzed the data to reconstruct the catastrophic sequence that unfolded in the wake of the collision. Following the initial impact, an enormous tsunami towering over 800 meters would have surged across the Atlantic Ocean, leaving destruction in its wake. Dr. Nicholson elaborated on the chaotic aftermath, explaining that the central uplift formed by the impact caused surrounding soft sediments to flow inward, creating a visible brim around the crater. The earthquake induced by the impact appears to have liquefied sediments beneath the seabed, triggering faults and fissures below the ocean floor. Evidence of large landslides emerging from the collapsing plateau margin has also been uncovered, illustrating the sheer power of this geological upheaval. The scientists noted that, as the tsunami waves radiated away from the crater, they were followed by a backflow that created resurged scars, serving as a testament to the catastrophic nature of this event. Despite the scientific community's excitement over this significant discovery, it's been 116 years since humanity has witnessed an asteroid of similar proportions. Yet, according to NASA, the threat of another massive space rock striking our planet looms ever closer. The U.S. Space Agency has determined that asteroid Bennu, a near-Earth object, has a 1 in 2,700 chance of colliding with Earth on September 24, 2182. The potential for catastrophic events like these underscores the importance of continued monitoring and research into near-Earth objects. This newly unearthed evidence of the Nadir crater stands as a chilling reminder of the cosmos's unpredictable nature and the potential for catastrophic events that could reshape our world in an instant. As we look to the future, the specter of these ancient impacts serves as both a cautionary tale and a testament to the resilience of life on Earth, reminding us of our place within the vast, dynamic universe that surrounds us. How the dinosaurs became extinct. Scientists have uncovered a chilling record of the day the dinosaurs died, an event that forever changed life on Earth. This haunting story is revealed in a 130-meter core of rock drilled from beneath the Gulf of Mexico. The sediments within this core chronicle the catastrophic moment when a colossal asteroid struck, triggering the extinction of the dinosaurs and paving the way for the rise of mammals. In 2016, a UK-US-led team embarked on this monumental quest, spending weeks drilling into the remnants of the impact crater, a vast structure spanning 200 kilometers wide beneath Mexico's Yucatan Peninsula. The best preserved central portions of this crater lie just offshore from the port of Chicxulub. Among the significant cores of rock retrieved, it is this specific 130-meter section that vividly recounts the first day of what geologists call the Cenozoic era, a period forever known as the Age of Mammals. The asteroid, a terrifying 12-kilometer-wide behemoth, slammed into Earth, gouging a massive hole in the crust that created a crater 100 kilometers across and 30 kilometers deep. This cataclysm unleashed a chain reaction, causing the bowl-like formation to collapse into a crater measuring 200 kilometers in diameter. The center rebounded and collapsed again, forming an inner ring, forever memorializing the violent forces unleashed that fateful day. Much of this ancient crater now lies buried beneath 600 meters of sediments offshore, its terrestrial rim obscured by limestone, traced only by a sinister arc of sinkholes. The extracted core reveals a chaotic mix of shattered materials, yet it tells a clear and terrifying story. The bottom 20 meters are dominated by glassy debris, rock melted by the searing heat and pressure of the impact. This molten material spread across the crater's base moments after the collision, encapsulating the raw fury of that instant. What follows is a sequence of fragmented melt rock, remnants of explosive reactions as water rushed back into the crater, igniting violent reactions reminiscent of volcanic eruptions when magma meets seawater. This tumultuous phase spans the first minutes to an hour after the impact, transforming the crater into a cauldron of chaos. The upper 80 to 90 meters of the core section consist of debris from this turbulent water, starting with larger fragments and followed by progressively finer materials. The deposits align with the initial hours after the collision, painting a vivid picture of a landscape in turmoil. At the very top of the 130-meter core lies striking evidence of a tsunami, with sediments arranged to indicate a high-energy event. The impact unleashed colossal waves that crashed against shorelines hundreds of kilometers away, bringing debris back to the crater, an enduring reminder of nature's unfathomable power. "This is all still day one," remarked Professor Sean Golick from from the University of Texas at Austin. Tsunamis move at the speed of a jet plane. 24 hours is a generous amount of time for the waves to move out and come back in again, he stated during an interview with BBC News. His team stands confident in the tsunami interpretation, as mixed within the deposits are soil markers and charcoal remnants of massive fires ignited on nearby land masses due to the intense heat of the impact, all swept back to the crater by the returning waves, painting a haunting tableau of devastation. The absence of sulfur in the 130-meter core is astonishing, especially since the asteroid likely struck a sulfur-rich seafloor. This lack supports the theory of the dinosaurs' extinction, as a catastrophic sulfur release could have cooled the climate dramatically, threatening countless species. An estimated 325 gigatons of sulfur would dwarf even massive eruptions like Krakatoa. While dinosaurs perished, mammals survived, transforming the world. This discovery not only sheds light on that fateful day, but also enhances our understanding of Earth's history and the fragile balance of life amid cataclysmic events.